All right, welcome to the explainer. You know, if you've ever tried to mash up data from a few different places, you know it's never a clean process, is it? It's probably one of the most common and, let's be honest, most frustrating parts of being a data analyst. So today we're going to tackle the S8 Data Analyst Standard head-on, which is all about how you combine data sources without, losing your mind. Let's get into it.
I mean, does this look familiar? Of course it does. You've got one file from a database, another one that's just a spreadsheet someone emailed you. One system calls it postcode, the other says zip. And the dates? Oh, the dates are just absolute chaos. This is the reality of our work. But having a clear method, well, that's how you bring order to all that chaos.
So, to make this all feel a bit more real, we're going to put on our detective hats and solve a case. We'll be data analysts for, let's say, a fictional food delivery app called Hungry Now. And our mystery? We need to figure out why customers in certain neighborhoods are complaining about late deliveries. Time to crack this case.
Right. So our first big challenge here is that all the clues we need are scattered all over the place. The complete story isn't just sitting in one nice, neat file. Nope. It's spread across 3 totally different systems, and it's our job to bring it all together.
Our investigation is going to pull from these 3 key sources. First, we've got the delivery system. This gives us the hard facts, the when and where, all those crucial timestamps. Then there's the restaurant tool, which tells us what happened. How long did it actually take to prepare the food? And finally, the customer support platform. This is where we hear from the who, the actual voices of the customers. Each one holds a really vital piece of the puzzle.
Okay, so before we even think about joining these files together, we have to do the prep work. You know, a good detective never mixes evidence without examining each piece carefully first. It's time to clean up our clues. So where do you even start? Well, first things first, you gotta profile your data. You look at each source individually and you ask, what's in here? What are the key columns? And most importantly, is there a golden thread that can link these things together? And in our case, it looks like the order ID is in at least 2 of our systems. Boom, that's our main connection. Now, here's a classic trap we have to avoid. We have to understand the grain of our data. And that just means, what does a single row in this table actually represent? So in our delivery data, 1 row equals 1 order. Super simple. But in the customer support logs, one angry customer might send multiple messages about a single late order. That means multiple rows for the same order. If we get that wrong, our results will be completely skewed. This right here, this is the magic. It's the transformation from chaos to order. On the left, you've got the raw data, right? All the confusing date formats, different names for the same exact thing. But on the right, that's our goal. Everything is converted into a single universal format. For timestamps, that's ISO 8601 UTC. It is the gold standard. This isn't just tidying up. We're basically creating a common language for our data to speak. So yeah, in a nutshell, standardization is just about creating that common language. It makes sure that when we ask our different data sets to talk to each other, there are no misunderstandings. When we match postcode to postcode, we know for sure we're talking about the same thing every single time. Okay, with our clues all cleaned up and prepped, it is finally time for the main event, connecting the dots. This is where we fire up our tools, SQL, Power Query, Python, whatever you use, and we merge those separate sources into one beautiful master file. Our strategy is a 2-parter. First, an exact join. The delivery and restaurant data both have that clean order ID, so we can link them together perfectly. But our support tickets don't have an order ID. Bummer. So for those, we use something called a fuzzy match. We're going to try to link a complaint to an order if their timestamps are within, say, a 5-minute window of each other. Is it perfect? No. But it's a really smart workaround when you don't have a perfect key. Now, whenever you join data, you've got to make a choice. And a really common one is between a left join and an inner join. You can think of it like this. An inner join is like an exclusive club. Only records with a perfect match in both tables get in. A left join, on the other hand, is way more inclusive. It keeps everything from your first table, your left table, and just pulls in matching info from the second, leaving blanks if there's no match. So for our investigation, we chose a left join. And this was a totally strategic decision.
We needed to see all deliveries, even the ones that didn't have any restaurant data or a customer complaint attached. Our main goal here was completeness, seeing the whole picture, rather than the purity of only having perfectly matched records. And the result of all that careful work? A 92% match rate. That is a powerful number. It tells us our strategy worked really well and that our final dataset is pretty solid. But just as important, it tells us what's missing. That other 8% of unmatched records, that's a key piece of information we have to document and understand for the next step of our investigation.
But hold on, we're not done yet. A successful project isn't just about what you connect, it's also about what could be wrong. A good detective always anticipates the traps, and that's why our next step is to formally identify and document all the risks in our data. This shows you're thinking critically about the quality of your evidence.
These are some of the classic traps you'll run into. You've got missing join keys, just like we had with our support tickets. You could have duplicate records that are going to throw off all your counts. Or you might have different definitions for things. Like, what does delayed even mean? Is it 5 minutes late? 10 minutes? Agreeing on these things is absolutely critical.
And the absolute best way to manage these traps is with a risk register. This is your logbook. For every risk you find, like the missing order ID, you write down the potential impact. In this case, a lower match rate. And the mitigation, the thing you did to fix it, like our 5-minute fuzzy link. This is what professional-grade data work looks like. So, you've done the work, you've solved the mystery, you've managed the risks. Now you have to prove it. For any of you going through an apprenticeship, this part is for you. This is how you package up your work for your portfolio and your endpoint assessment.
The absolute key here is to take ownership. Don't say the data was joined. Say, I joined the data. You want to use strong, confident I statements that walk the assessor right through your thought process, your actions, and why you did what you did. You are the detective who cracked this case. Own it.
So, for your portfolio, you need to turn your actions into powerful evidence, just like these statements here. Notice the pattern? You're not just saying what you did, you're explaining your method from start to finish. You talk about the initial profiling, the specific standardization choices you made, your exact join strategy, and this is the most important part, the rationale behind your technical decisions.
And that detailed story just keeps going. You also need to show how you validated all your work. As you can see here, that means you quantified the data quality with hard metrics, like match and null rates. It means showing your risk register, and it means explaining the impact of any data you had to leave out. This level of detail, all the way down to a reproducible query, that's what separates a good analyst from a great one.
And hey, if you're really aiming for that distinction grade, get ready for questions like this. This gets right to the heart of your decision-making. Our choice of a left join, for example, that was a trade-off. We decided to prioritize completeness, seeing all the deliveries, over the accuracy that a stricter inner join might have given us. Being able to explain those trade-offs, that is a sign of a really mature analyst.
So, let's wrap this all up. Combining data from different places is always going to be a challenge. Look, messiness is pretty much the default state of data in the real world. But it's not something you need to be afraid of. If you have a structured method, profile, clean, join, validate, and document, you can turn that chaos into clarity every single time. Every data detective has that one case, right? The one that really, truly tested them. So my final question for you is this. What's the messiest data mystery you've ever had to solve? I bet there are some incredible stories out there. Thanks for tuning in.